Learn beyond the infinity. Future starts here.
Hello everyone, welcome back to Quantum Explorer. In today's video, we will discuss about part 2 of recursion. We will solve problem on recursion. See, there are many problems in recursion, but these three basic recursion questions will give us more clarity about recursion, what is backtracking, and how to use recursion in different cases. Print linearly from 1 to n, and reverse is your homework. Sum of first n number and power of a number means a raised to n. So let's begin. Question is print from 1 to n. What it means? It means that if user give 5 as an input and output, we should give 1, 2, 3, 4, 5. If user give 4 in output, we give 1, 2, 3, 4. We need this kind of output and we have to write code using recursion. Let's see how to write this. First of all, we have main function. Inside main function, first of all, I will declare a variable n and I take input from user cin of n. Then I make a function outside the main function f which take n as a parameter as integer data type. Inside main function, I want to print value from 1 to n. First of all, I declare outside its global variable count as initial value 1. Set this f function, I print this count, and every time I increase value of count by 1. First of all, understand how it works. In output, let's say I give 5 as an input. So how it works? This function will print count. Initial value of count is 1. Count value increases, and next time this function will print 2 because value of count become 2. Third time, value of count become 3 and function print 3. Value of count become 4. Fourth time, function will print 4, value of count become 5. Fifth time, function print 5 and value count becomes 6. It happens till infinite. It never stops because we don't give any base condition to our f function. What is base condition? Our function has base condition that when the value of count became value of n, means when count become n and last time it prints stops, means further no requirement of printing. This is the requirement of our function and this is the base case. If value of count equal to n and print count and return. Let's understand this code by recursion tree and an example. After increment of count, I call this function recursively for count, and inside main function I call this function for n. How it works? First time when the compiler comes here, these lines of code will be implemented. Compilers comes here and compilers goes towards this main function. In this function, value of count is not equals to n. This condition is false. Print count. Output we can see 1. Value of count become 2. And again this function is called for f of 4. Again value of count is not equal to, and value of count is 2 which is not equal to 5. This condition is false. Again an output we see 2 as the output. Again this function is called for value of count is equals to 3. Again this condition is false. In output we see 3. Again value of count become 4. This same function is called. This condition is false. In output we see 4. Value of count become 5. Again this function is called. Now this condition is become true. Last time value of count is printed and this time function will return. Means no lines of code are and no lines of code implemented again. I will look in recursion tree. First of all, this function is called f of 5 and the value of count is 1, so 1 is printed. Then this function is called 2 and the value of 2 is printed. Again, this function is called value for 3, 3 is printed. This function is called 4, 4 is printed. When value of count becomes 5, 5 is printed and this function will return and the final output is 1, 2, 3, 5. So this is about all this question. Let's understand next question. Second question is said that take input from user of and return output of sum up to 1 to n. What it means? Let's say user give input as a 5. We should return it 1, 2, 3, 4, 5 means 15. If user will give 4 as an input, we should give 1 plus 2 plus 3 plus 4 with 10 as output. How we implement this in code? First of all, inside main function, after taking input from user outside the main function, I'll declare another function which take parameter n. Outside both of the function, I declare a global variable sum which has initial value is equals to 0. Logic of this question is same as the previous question. When this function is called for n, value of sum is initially value of sum is 0. This time this function will first of all this function will do value of sum is equal to value of current value of sum plus n and again value of n minus minus when value of n is decreased by 1. First of all, we understand these two lines of code how it implemented and then we add base condition. Let's say input is 5. Initially the value of sum is 0. When this function is called sum is equals to sum plus 1 means value of sum is 5 and this time value of sum is 0 and value of sum will become 0 plus 5 means value of sum now is equals to 5. Next time value of n is 4 and when I call this function for f of 4 this time value of sum is 5 plus 4 then value of sum become 9 then value of sum is equal to 9 plus 3 then 12 plus 2 and then 14 plus 1. This is how this will run and here instead of 4 I will write n for generalize. And what is base case? Base case is that when the value of n becomes 0, stop the recursion. So base case is if value of n is equals to 0, return. Let's take an example of n is equals to 4 and understand it in output. First of all, compiler come towards this main function. Value of n is a 4 and inside main function it is called for f of n. When compiler come here, n is not equals to 0, this condition is false. So value of sum, initially value of sum is equals to 0. Value of sum become sum plus 4 means 0 plus 4 is equals to 4 and become value of n become 3. Again, this function is called again. Value of n is 3 which is not equals to 0. So again sum is equals to sum plus 3. So value of sum is become 7. Again n is minus. So same this function is called n is 4 n is equals to 2. This condition is false again. So value of sum becomes 7 plus 2 is equals to 9. Again value of n decreased by 1. This time the value of n is 1. Again the same function called. This condition is false. So value of sum becomes 9 plus 1 is equals to 10. Again value of n is decreased by 1. It becomes 0. Again this function is called and this time this condition is true and function will return at in output we can see 10. So this is all about sum of n numbers. Let's go towards next question. Third question is say that power of a number a to n It means if user give in input value of a is equals to 3 and value of n is equals to 2, so in output we should return 3 raised to 2. If user give value of a is equals to 5 and n is equals to 4, so we should give 5 raised to 4. How we do that in code using recursion? Let's understand. First of all, from user I will take input of a and input of n. So I declare two variable a and n. Then value of a and n I will make input. I make here a function named power which take two parameters a and n. Inside this function, inside this function value of n decreases by 1 and this function will return a into power of a into n. First of all, understand this line and after we will add base condition. How it works. Let's say value of a is equals to 4 and the value of n is equals to 3. When the first time this function is called, value of n decrease by 1. So value of n is 2 and 4 into power of 4 into this will give 4 into power of 4 and 1. This will give 4 into power of 4 and 0. When n becomes 0, this is our base case and from here backtracking is start. The value of this power function 4 comma 1 is 4. So ultimately for this part value of this part becomes 16. Well, for this value of power of 4 comma 2 is 16 and ultimately it becomes 64, which is 4 cube our answer. But here we should add the base condition is that when the value of n becomes 0 we must stop recursion. So I add here if n is equals to 0 return. Let's understand this for an example of n is equals to 5 using recursion tree. Inside this main function I call this power function for a comma n and the value of a is equals to 2. P for power, first time this function is called for 2 comma 5. For this function it will work as 2 into p of 2 comma 4. Again this function is called, this will work as 2 into p of 2 comma 3. Again 2 into p of 2 comma 2. Again 2 into p of 2 comma 1 and again 2 into p of 2 comma 1 2 comma 0. Here the base case hit, so from here this will return value of 2 comma 1 is 2, so ultimately value of this part is equals to 4. Value of 2 comma 2 is 4, so value of this part is 8. Value of 2 comma 3 is 8, so value of this part is 16. Value of 2 comma 4 is 16, so value of this part means value of 2 comma 5 is 32 is equals to 2 raised to 5 and this is our answer. So I hope you understand about all these three questions and understand what is recursion. In next video we will discuss more about recursion in depth and we will solve more questions.